My presentation, online general education math course. We've been running the online math courses since 2009. Just give a little bit of an idea of one of the classes. We actually run 3 online courses. One of Math 105, which is cartography, Math 108, which is what I'm going to talk about real quick, and which is a general practical math course, and Math 131, which is our applied calculus course. The Math 108 online course does satisfy the Gen Ed requirement. It's a little bit different than your typical class. It's not a algebra course or a calculus, so no integrals or derivatives to work on. We focus on real-life applications and real-life problems. I like this quote from my spring 2010 class from the student. Gets away from the black and white of math and has a different aspect, which makes it more interesting, at least to me. So we get away from some of the plug and chug, often referred to type of problems, and get into problems that are a lot more fun. Teaching mathematics online is very different than teaching it face-to-face. A face-to-face class requires extensive verbal communication between student and instructor, a lot of lecture, and a lot of interaction. A lot of times you can actually see what's going on with the students as you're lecturing to them, whether they're understanding what you're doing. So you have a lecture, and you have question and answers. You do a lot of reminders. Several projects are being done so that you can make sure the students understand. One of the biggest things that I see a lot of times in lecture versions face-to-face is students helping students. We'd like to mimic that on an online course. So that's what I have here. I want to simulate these essential communications for online. So you can't just take a class and create a web page and throw everything up there and say, here it is, off you go. And it doesn't work. And it's actually, I've seen some people tried that and courses have failed that way. If you just put up a bunch of material and you don't come back to that class until the end, it doesn't work that way. And there's a lot of literature out there. There's just, here are some quotes from some of the literature. Knowledge is acquired by construction, not transmission. You can't just place it out there. And when you're designing this, you have to keep in mind the students. You have to design the course specifically for it being a math class. I've used Sakai for this, and there's a bunch of the tools that I've used in Sakai. So when I take this, and I broke it down into some different parts for the Sakai site: communication, assessment, and the outline of the course. The communication is the announcements, schedule, messages, and emails. And then, of course, a discussion board, which I'll talk about in a moment. And then the assessment is the assignment tools, the quizzes, the grade book. And again, discussion boards, which will be graded. The outline of the course is done with modules, table of contents, a syllabus is thrown up there. So, of course, you put it all together, kind of construct it. And the reminders are very important, especially for an online class. Students need to be reminded constantly that homework is due or the discussions are due. You have to send out a lot of emails to make sure students are participating. But one of the important things here is the discussion boards. I feel that the discussion boards for an online course are the driving force for the class. When I first designed this almost 4 years ago, I was students, or when we were going on the online fellows, some of the other disciplines were using discussion boards, and I was trying to figure out how I can incorporate that into the class. And it turns out that that actually was the most important part of the course, because it keeps the students interactive. The students will participate in the discussions. I post the first, so my method here is I post the first topic and I allow some time, usually a week, for students to post and respond. And the students are required to respond to my posts, are required to respond to other students' posts, And they're also required to interact. That's part of the grading. That's part of the grading rubric, is to interact with the other students. If they don't interact, then they'll be marked down. And I have a class about the size of 15 students. I've had up to 65 postings on a particular topic, so they are interacting in this course. Collaborative learning is very important. That's that student helping the students. So a lot of times on the discussion boards, students will say, I didn't realize or understand that concept until another student actually explained it to them. Just some examples of my discussion topics. One here is if you're recommending to the mayor of Providence about street sweeping routes, how would using the theory, how would you go about it? We talk about circuits, Euler circuits, Hamiltonian circuits, and so on. And the students go out and they figure out, they take a map and they figure out what's going on and how they write up a recommendation. Another topic was the 2000 presidential election. In this course, we talk about voting procedures. There's 4 or 5 different voting procedures we talk about, and then we simulate what would happen if there was a different type of voting procedure that was used for that election. And the students go through and they discuss this. This is a very lively discussion. And this is also one when we talk about consumer price index. Students never realize that it's that the stamps, buying these forever stamps, should you stock up on them, that they've actually are below the pace of inflation as they raise the price. So it's not that great of an idea to stock up on them. So those are just some examples of that. I often get questions from people, how do students submit their homework in a math class? Because you got these drawings and that. Well, the students take pictures with their smartphones. They write them out as if they're in class, and they take a picture and they upload it. I want to involve students in the math course similar to a face-to-face class, sending them up to the board. So I want to be able to mimic this process in an online course. One of the things I did is I required students to download a computer program called Jane, which is free. It's similar to a Camtasia or video capturing system. And I'd give them a project to do, and they would have to video capture their screen. So this is a picture of one student who actually did this. This is a student describing how to solve this is error analysis in the course, transmission errors. This was nice getting the student involved. However, the problem with this, there was no immediate feedback. I had to wait until after the student submitted this. Then I'd go in and listen to it, but there was no feedback. I had to get the feedback after I graded this problem. So I changed this. This is what it says right here. I wanted the limited amount of work because many students were unhappy with having to go out and download a separate program. It proved to be actually too much extra work to do that, and I can't give them immediate feedback. But it did, the projects of the students that did do them, it did help them understand the material. And I was able, when I did give the feedback, I did find students doing some things incorrectly, and we were able to discuss that. So I changed this. This is a different one. This is actually, I had students write a one-page memo. This is the campus map, doing Euler circuits or Hamiltonian. You go around to different, like you're tracing a bus route, going around and dropping people off and coming back to where you start. Find the most efficient route. This is something we talk about in class. But instead of having them write this up, I actually had them do the big blue button in Sakai. So there's a picture of me sitting in my home, and there's a picture of a student at her house. And she was describing to me how she would go about this route. And you can see that she had the control and the blue, and she was going about the route and going around, and we were talking about it. She made a couple mistakes, but this had immediate feedback, and she was able to understand the Euler circuit very well from that point on. The only problem with the big blue button at this moment that I see is that it's not mobile friendly, and it requires flash, and the iPad and the phone are not flash friendly. We now we created a mobile version for the online site. if you see how this is one of the web pages that I use, but if you were to look at this on a mobile phone, it doesn't resize it correctly. The links are too small for your fingers to touch on there. And what we're finding, this is one of the statistics, is that most students are now, they're accessing all these things on their mobile phone. So you need to make any online course very mobile friendly, because all the content is delivered that way. So I changed the website. This is how the website looks on a web page, and when you go into the mobile version, it resizes it correctly. It's easier to see in this right here. But these are the links. All the links appear at the top, and you would press your finger on those, and you can go to all the different pages very quickly. In fact, this is the site right here. The students would just press on this. It's actually, the way it's set up, it's very fast. There's a bunch of videos. Lecture notes are also on here, PDF versions of the lecture notes. So it downloads it very quickly. So the mobile version of the site works very nicely on the iPhone and on the iPad and so on, and also on the Google devices. The lecture videos were all done on Accordant. However, Accordant is not mobile friendly. In fact, you cannot see these on a mobile device because it requires Microsoft Silverlight. So all those have all been changed to YouTube videos, and all the YouTube videos are only about 10 minutes long. So they're modular in a sense. So you click on the video, it's just right about that concept. Students can see the concept. They can also have the notes and go through the notes. And this is exactly, you can see on your phone. So that's the course continues to be updated. New projects have created all the time. That's the website if you wanted to see that. And what's coming up next? Massive open online courses is the next investigation. I'm not real sure where that's going to go, but that is gaining a lot of momentum right now, and it's something that should be investigated. That's it.
I mean, it's the math and the science. They can't really get it online.
This they can, because a lot of people bring, a lot of students I get for this course are not your typical students, and they bring their knowledge from things that they've done in the real world. Someone was running a business, and she was talking about the traveling salesman problem, the best way to ship things, and she was, it was very interesting, the concept that she would bring. Students bring in the ideas of Euler circuits or Hamiltonian, how to go to each bus stop or how to go to each class in the most efficient way. They like to figure that out. So it's not your typical algebra-based class, and the students really enjoy this. So it's fun. It's more enjoyable, especially the discussion boards. They get to discuss with the other students, and they talk about the problems. And it's fun.
What do you see as the biggest challenge right now with the online courses? Like, what challenges still need to kind of be addressed to get it to that kind of optimum?
The challenge, well, there's a lot of preparation on the instructor's part beforehand. So it took a lot of time to get the course set up. And that's one of the challenges, is we only have 3 online courses because it's so much prep at the beginning. A lot of instructors don't want to put it all, spend all that time. And then it's the upkeep of the system as you're going along. Things keep changing, like that Accordant system. I spent a whole semester recording all these lectures, and I used them for a little bit, and then I found out they could no longer be used. Then I spent another summer doing all the topics, or all the short Camtasia videos. So if things start to change, then I'd have to change that. So you have to keep updating. That's probably the biggest challenge, is to consistently update. The book will change, then my entire outline will then change, and then it's the constant changing. It's easier when it's face-to-face in a lecture because all that stuff's not already
Yeah.
up there, and you like to refer back to it and not have to make all those changes. And then if you change a video, then it's very time consuming to go through and change that. The other biggest challenge is the interaction with the students. You want to make sure that they're interacting, that you don't want to make them passive learners. You don't want them to just sit there and not do anything. And so you try to make sure that they are interacting. The Big Blue Button was a lot of fun. The students really like
And
that.
what is the big blue button? I'm
It's
not
in
that-
Sakai. It's an interaction in Sakai.
Uh-huh.
This right here. So it's an interaction in Sakai, and the student, so they can be at home at the computer, and it's basically, that's the board. This right here is the board, and I can give her control, or I take control. So I can then mark on this, and then I give her control, and then she can use her mouse and go mark on it, and then we can type questions. And then if they have a microphone, then we can hear each other, and we can just talk to each other. You can see me typing, "Can you hear me?" And if some students couldn't because they didn't have microphones, we just typed over there. But the interaction was great, and students like that because then it's immediate feedback. No, you're not following this concept correctly. So this is within Sakai. You can then there's a link from there, and then it goes. But it uses Flash, so it's not very mobile friendly.
And do you think, you said you have 15 students, is that kind of a good number? Could you have done it with 25?
I limited the class to 20. This is not, the way this is set up is not a good idea for a large course. So that's the next challenge, is if you want like the massive open online course where you have thousands of students, then this has to be changed so that maybe this can be used where I have anybody coming in at a certain time. So I'll be like, at 1 o'clock, I'm going to now present, and they can all log in. Or I don't know if that can handle that type. Probably don't know if that can handle that many people. But it has to change. You can't monitor that kind of system with that many students. But 15 to 20 students, it's good size. It's manageable.
For your information, students have no problem with their microphone headsets, they now have a telephone coverage, so people can use their telephone.
They can use their telephone now? Okay, see, I did this last summer. I'm going to do it again this summer.
Since last week.
Since last week. Okay, because I'm going to redo this summer. This was last summer when I did this, so I'll redo it this summer.
So there will be a telephone number on the beginning of the chat screen.
Okay, well that would be great. That would be very
A lot of
nice.
students have a problem with their audio.
Yeah, the other thing I had the students, I allowed them to do was text me. I opened up a Google account, and they could text me. And several did. They didn't know they couldn't call it because I didn't have it set up to receive calls. But they would text. And then that's another way we communicated over the summer. They would text me questions through the Google account, and then I text back. I didn't want to give them my cell number.
So is this going
And
to
young
summer?
people like to.
This one's on the summer. It also runs, another person's teaching a different version of this during the spring and the fall. So it's been running all semester. It's been running since 2009.